Hello Math 20-2 and welcome to your 6th lesson on statistics. In this lesson, we're going to learn how to use this graphing calculator instead of the tables. So I could save you some time. We're learning a more efficient and faster way, and it can help us find the z-scores in between 2 points, which is a lot easier than looking at the tables, adding, subtracting, so on and so forth. So here we go. These first 2 pages here show you, first two pages in your book will show you how to do it on the calculator. Now the next page we're going to look at here, it says, first question it has about postal outlets, okay? So we have postal outlets determined that using standard mail service, it takes on average, it takes 3 weeks on average from China to arrive to address in Canada. So to send something from China, it will take 3 weeks on average. They also determine that standard deviation is 5 days and that it is normally distributed, okay? So it says determine the probability to the nearest hundredth that the package will take less than 5 days to be delivered. Or less than 15 days. So what do we know here? I know my mean is equal to 21 days, 3 weeks, right? 21 days. I know my standard deviation is equal to 5. And I know my max wanted is 15. So now what we're going to do is we're going to use our normal PDF here. So let's go here. We're going to go second, and then we're going to go to the bars right there, okay? And we want a normal PDF, or normal CDF, sorry. So we're going to go there. Now my lower, I have right here some ridiculously low. So I said 1e to the negative 8. So I went negative 1, and I went second e to the 99, okay? My upper, I'm going to say, is 15. That's my max. Now, because we want everything less than, my mean, we said, was 21, 3 weeks. My standard deviation is 5. And I'm going to graph it. So I get something like that. Now, let's take a look at this. I end up getting 0.115. Oops, hopefully you saw that. So we have 0.115. So what is the probability? So to determine the probability is 0.115, or to the nearest hundredth, 0.12 is my probability that it will be delivered less than 15 days. So we only have like 12% chance, which isn't very high. Let's take a look at question B. It says, postal outlets guarantees that the package will arrive in less than 35 days, or the delivery is free. Now, we have this many packages, 8,257 packages, were sent from China to Canada. Okay, how many of these packages would you expect to be delivered free of charge? Well, first of all, we have to find the probability that it is more than, will arrive in less than 35 days. So if it's 35 or more days, so when I want my min to be 35. So we're going to do the same thing as before, except now my minimum is 35. So let's go back here, second, varsity. We want the normal CDF. Now my min is 35. My max, I'm going to say, and go like that. Mean is the same, standard deviation is the same, and I'm going to paste. I get around not even 2%. So it's not even 1%. So it's 0.025. So we have 0.026 probability. Oops, 0. Okay? Now it says how many of these packages will be there. So I'm going to have to times that by the probability, 8257. So I multiply that by, see right there, multiply by 8257. Now I get 21. So there will be around 21 packages for free. Okay? Next question here says, calculate the percentage of population to nearest tenth whose height is more than 1 standard deviation above the average height of the population. So let's take a look. Here's what I mean. We want everyone whose population is more than 1 standard deviation above the average height. So 1 standard deviation. Okay? So here, let's take a look at that here now. So I'm going to say the mean, if we looked at before, my mean is 0, and we want 1. Okay? So my standard deviation is 1. So I'm going to go same thing. We want to do this. Now my lower is going to be 1, because we want above. My upper is keep it the same. Now my mean is 0. My standard deviation is 1. Okay, because we're just counting by 1s. Whoops. I have to redo that again. Put it in there. Oh, my upper is, oh, let's go back here. We have 1. My upper is 1. Okay, hopefully you saw how I did that. Okay, I did 1 second e to the 9. Now my mean is 0. We have 1. Okay, because my lower is this. My upper, well, I could go on forever, but my lowest is that there. So I'm going to push enter. And I'm going to get 15.8, which is 15.9%. See how that works? We'll be taller than 1 standard deviation above. Now, the next one is the inverse norm. So when do we do inverse norm? So if we're given the area of the data value, so the inverse norm is if we're given the percentage or probability. If we're given the area, or we're given the percentage or the probability, that is when we do the inverse norm. So here's some examples. So it's working the opposite, the inverse. So here it says determine the z-score to the nearest hundredth if 1% of the data values lies above the z-score. So we want 1 above. Okay? So we go inverse norm. Second. Nope, there we go. Of course, we have to go to inverse norm. And we want 1 above. So my area is 0.01, because that is 1%, right? My mean is 0, and then 1. I end up getting negative, whoops, just wait, is determine the z-score of the area whose, oh, that's not the minimum, is, sorry. Okay, so we have area 0.1, and we want above, yep. So we want determine the z-score to the nearest hundredth if 1% of the data values lies above the z-score. So remember, it's normally distributed, so if I have this here, that's 1 less, so we want 1 above, so I'm going to have to go the exact opposite. So this is negative 2.326, this is going to have to be 2.326, so my answer is going to be 2.326, okay? And it says determine, so that's 2.33 is my answer, okay? So that's how we would do that one. Now, in other words, we could have also done it, because we want to know how much is less, I could have put it in here and said 0.99. Oops. I'm making a calculator mistakes. 0.99. And I could go that way, and then we get 0.33. Because we want how much under. We want this here, which is equivalent to that there, or we want all of this, which is 99%. Okay, so there's 2 ways of looking at it. Hopefully you understood that. Good luck as I see you tomorrow as we work on these questions together.